Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter sets and relations. So any doubts if you have, please write that in the comments section. We shall obviously clarify them. Also some important homework questions on every chapter of maths will be uploaded in the Sapience Education application. So please install our Sapience Education application whose link has been provided in the description. So here it is told the set A, it contains the elements 2, 3, 6 and 7, and set B contains the elements 4, 5, 6 and 8. Let R be a relation defined on A cross B where A1 comma B1 is related to A2 comma B2 if and only if A1 plus A2 that is equal to B1 plus B2, then the number of elements in the relation R is. So we have to find the number of relations, the number of elements in the relation R. So the sum of A1 plus A2 that can be, so here A1 and A2 that belongs to the set A and B1 and B2 will belong to the set B. So A1 plus A2 that can be 2 plus 2 which can be 4, or it can be 2 plus 3 that is equal to 5, or it can be 2 plus 6 that is equal to 8 and 2 plus 7 that is equal to 9, or it can be 3 plus 3 that is equal to 6, 3 plus 6 that is also equal to 9, 3 plus 7 that is equal to 10. So now mm, then 4, no, then 6 is there. So we can have 6 plus 6 that is equal to 12 and 6 plus 7 that is equal to 13. And we can also have 3 plus 2. 3 plus 2 is 5. And then we can also have 3 plus 6, 3 plus 7. Then we can have 6 plus 2 also. 6 plus 2 is 8. 6 plus 3 also, that is equal to 9. 6 plus 6 and 6 plus 7. Then we can have 7 plus 2, that is also 9. 7 plus 3, that is also 10. 7 plus 6, that is 13. Then 7 plus 7, that is equal to 14. So therefore it means the sum can be sum of A1 and A2, that can be 4, 5, 6, 8, 9, 4, 5, 6, 8, 9, 10, 12, 13 and 14. And similarly, the sum B1 plus B2 that can be B1 plus B2 can be 4 plus 4 that is equal to 8. And we can have then 4 plus 5 that is equal to 9, 4 plus 6 that is equal to 10, and 4 plus 8 that is equal to 12. And then we can have 5 plus 4 that is equal to 9, 5 plus 5 that is equal to 10, then 5 plus 6 that is equal to 11, 5 plus 8 that is equal to 13. Then we can have 6 plus 4 that is equal to 10, 6 plus 5 that is equal to 11, and 6 plus 6 that is equal to 12, and 6 plus 8 that is equal to 14. And we can have 8 plus 4 that is equal to 12, 8 plus 5 that is equal to 13, 8 plus 6 that is equal to 14, and 8 plus 7 that can be, that is no, sorry, 8 plus 8 that is equal to 16. So therefore these can be the sums. Therefore the sum of b1 and b2 that can be sum of b1 and b2 that can be 8, 9, 10, 11, 12, 8, 9, 10, 11, 12, 13, and 10, 11, 12, 13, 14, and 16. 14 and 16. Therefore, we have to find the common sums. Now, therefore, the common sums can be, so common sums, it means that the sum of b1 and b2 that should be same as the sum of a1 and a2. So here 4 is not there, 5 is not there, 6 is not there, 8 is there. So 8 is common, 9 is also common, then 10 is also common, 11 is not there here, 11 is not common, so 12 is common, since 12 is here also and here also, and 13 that is also common, 14 that is also common, but 16 is not there. So these are the common sum. So for each, now for each common sum we will have an element in the relation R. We will have one element in the relation R. Since why? When the sum is 8, the sum is 8, then a1 and a2 that can be 2 plus 6 and 6 plus 2. Then a1, a2 that can be 2 comma 6 and 6 comma 2. Okay. So a1 comma a2 that can be 2 comma 6 or 6 comma 2. So it means 2 pairs it can be. And b1 comma b2 that can be 4 comma 4. So it means 2 pairs from the set A and 1 pair from the set B. So here we will have 2 into 1, that is 2 elements in the set R, 2 elements in the relation R we will get. Similarly, when the sum is 9, then a1 comma a2 that can be, sum is 9, so it can be 2 comma 7, 2 comma 7, 3 comma 6, and 6 comma 3, and 7 comma 2. So this is 2 comma 7, 7 comma 2, and 6 comma 3, and 3 comma 6. So 4 elements. And b1 comma b2 that can be b1 comma b2 that can be 9, which is 4 comma 5 and 5 comma 4. 4 comma 5 and 5 comma 4. So here we have 4 ordered pairs and we have 2 ordered pairs here. So it will be 4 into 2, that is 8 elements in the relation R. Then when the sum is 10, then a1 comma a2 that will be So when the sum is 10, then a1 comma a2 can be 3 comma 7 and 7 comma 3. 3 comma 7 and 7 comma 3. And b1 comma b2, that can be 4 comma 6, 6 comma 4 and 5 comma 5. 4 comma 6, 6 comma 4 and 5 comma 5. So this will be so here we will have 2 elements and here 3 elements. So 2 into 3, that is equal to 6 elements in the relation R. Then similarly, when the sum is 12, then a1 comma a2, that can be equal to sum is 12, so it means that it will come for 6 comma 6 only. 6 comma 6, and b1 comma b2, that can be equal to b1 comma b2, that can be equal to this 12, so it can be 4 comma 8, 8 comma 4, 4 comma 8, 8 comma 4 and 6 comma 6. 4 comma 8, 8 comma 4 and 6 comma 6. So here the number of elements in the relation are, that can be 2 into, no, sorry, this is 1 into 3, that is equal to 3 elements in the relation R. Similarly, when the sum is 13, then a1 comma a2, that can be equal to 13. So this is 6 comma 7 and 7 comma 3. 6 comma 7 and 7 comma 3. And so it can be 6 comma 7 and 7 comma 6. And b1 comma b2, that will be equal to, that will be, then sum is 13, so it's 5 comma 8 and 8 comma 5. So therefore here also we will have 2 into 2, that is 4 elements in the relation R. Then when the sum is 14, then a1 comma a2, that can be, so the sum is 14, so a1 comma a2 can be 7 comma 7, and b1 comma b2, that will be equal to, that will be equal to 6 comma 8 and 8 comma 6. So it means there are 2 elements, it will be 2 into 1, that is 2 elements in the relation R. So therefore the number of elements, the number of elements in the relation R, that will be equal to, so this is 2 plus 8 plus 6 plus 3 plus 4 plus 2. So this is 2 plus 8, that is 10, plus this is 2 plus 8, that is 10, 10, 6 plus 4, 10, 10 plus 5, that is 15. So that will be 25. So there are 25 elements in the relation R. So the answer is 25. Okay, then here it is told, in a survey of 220 students of a higher secondary school, It was so the total number of students on which the survey has been done, that is 220 in the higher secondary school. It was found that at least 25 and at most 130 students studied maths, and at least 85 and at most 95 studied physics, at least 75 and at most 90 studied chemistry, 30 studied both physics and chemistry, 50 studied both chemistry and um, mathematics, and 40 studied both mathematics and physics, and 10 studied none of these subjects. Then M and N respectively. Yeah. So 40 studied both. Okay, so 10 students studied none of these subjects. Let M and N respectively be the least and the most number of students who studied all the three subjects. Then M plus N is equal. So here actually we have a universal set and we have three sets. One is the set M, P, and C. So P is the set of all students who studied physics, and M is the number of students who studied maths, and C is the number of students. C is the set of all students who studied chemistry, and use the universal set. So here N of U, that is 220, and uh, the number of students who studied none of the subjects, it means it is N of uh, P union C union M whole complement, which means it is N of U minus N of P union C union M. So that is given as 10. So 10 students studied none of these subjects. So therefore N of P union C union M, that will be equal to N of U, which is 220 minus 10, that is 210 students. So 210 students studied either physics or chemistry or maths. It means at least one of the three subjects. Now it is given that the number of students who studied maths N of M, that is more than or equal to 125 and less than or equal to 130. And number of students who studied physics, that is at least, means at least 85 and at most N of P is more than or equal to 85 and less than or equal to 95, and N of C, which is the number of students who studied chemistry, so that will be more than or equal to 75 and less than or equal to 90, and 30 studied both physics and chemistry. Therefore N of uh, 30 studied both physics and chemistry, so N of P union C, sorry, P intersection C, both physics and chemistry. So N of P intersection C, that is equal to 30, and N of C intersection M, it means who's the number of students who studied both chemistry and mathematics, that is equal to 50, and N of M intersection P, of M intersection P, that will be equal to 40. M intersection P, that is equal to 40. So 40 students studied both maths and physics. Okay. So now we have to find how many, what is the least and the most number of students who studied all the three subjects. It means we have to find the range of the values of P intersection C intersection M. We have to find the range of this. So now, therefore, we can say n of P union C union M n of P union C union M, that is equal to n of P plus n of C plus n of M, then minus n of P intersection C minus P n of P intersection M minus P of C intersection M. Okay. Minus P, no, sorry, n of C intersection M then plus n of P intersection C intersection M. Since why we have added this common part 3 times, and when we subtract this common part, we are also again subtracting this part 3 times. So once we have to add it. So therefore, we can tell that n of P intersection C intersection M, that will be equal to n of P union C union M, that is 210 plus n of P intersection C plus n of P intersection M plus n of C intersection M minus n of P plus n of C plus n of M. So this will be 210 plus this n of P intersection C, that is 30 plus n of P intersection M, that is equal to 40 plus n of C intersection M, that is equal to 50, then minus n of P So now here we can say that the C plus n of M. Okay. Now therefore, for least value of n of P intersection C intersection M, that is equal to, is told M. So M will be equal to 210 plus 70. This is 120 minus the maximum value of n of P plus n of C plus n of M. So its maximum value is 130 and 95 and 90. So this will be 130 plus 95 plus 90. So then this will be equal to 330 minus, this will be 5, then 9 to the 18, 18 plus 3, that is 21, 2 plus 1, that is 3, 315, that is equal to 15. So this is equal to 15. So this is the value of M, and similarly the maximum value of n of P intersection C intersection M, that will be equal to n, that will be equal to 210 plus 120 minus the least value of n of P plus n of C plus n of M. So n, so that will be 125 plus 85 plus 75. 125 plus 85 plus 75. So this will be equal to, therefore n value will be equal to 330 minus 125 plus 75, that is 0. I plus 5, 10, plus 7, 9, 10. So this is 200. So this is 285. So this will be equal to 5, and then 8, 9 plus 4, 45. So n is equal to 45, m is equal to 15. So therefore m plus n value, that will be equal to 15 plus 45. So that will be equal to 60. No, sorry. The minimum value, this will be equal to 45. Minimum value is, this is 125, 85, and 75. 125, 85 plus 75. N is the maximum value. 125 plus 75, 200, 285. This is 330. 45, this is 45, and this will be 5. 130 plus 185, that is equal to 5, 11, 315. This will be 15. Okay, so 15 plus 45, that will be equal to 60. So 60 is the answer. So here it is told that let A be the set 1, 2, 3, 4 till 20, and let R1 and R2 be two relations on the set A such that A is related to B under the relation R1 if B is divisible by A. B is divisible by A, it means that A is a factor of B. And A is related to B under the relation R2 if A is an integral multiple of B, where M is some integer. So A is an integral multiple of B. So here it means B is a factor of A, or I can say A is divisible by B. So now the number of elements in R1 minus R2. R1 minus R2, it means from R1 we have to subtract those, we have to exclude those elements which are common to R1 and R2. It means R1 intersection R2, it means those elements which are where A comma A we should tell, since why A is divisible by A. So it means that R1 comma R2, it is 1 comma means R1 intersection R2, it is those elements which are 1 comma 1, 2 comma 2, 3 comma 3, etc. till 20 comma 20. And R1 is the set where B is divisible by A. So you can take 1 comma 1, 1 comma 2. Since here A should be a factor of B. B is divisible by A, it means A is a factor of B. So since 1 is a factor of every number, so it will go till 1 comma 20, and then till will be 2 comma 1. No, 2 comma 1 is not there. 2 comma 2 it will start. Will start from 2 comma 2 and 2 comma 3 till 2, 20, and then it will go till 20, 20. So now the number of elements in the relation R1 that will be equal to, so 1 is related to every element. So for 1 there are 20 elements. For 2 there will be from 2 to, it is related to all the numbers from 2 to 20 except 1. So there will be 19 elements. For 3 again there will be 18 elements. So like this it will go till 1, since 20 is related to 20 only. And here R1 intersection R2, it has 20 elements, 20 ordered pairs. So therefore n of R1 that is equal to the sum of the number of elements in the relation R1 that is equal to the sum of all the natural numbers from 1 to 20. So it will be n into n plus 1, that is 20 into 20 plus 1 by 2, n into n plus 1 by 2. So that is 20 into 21 by 2, that is equal to 210. And number of elements in the relation R1 intersection R2, that is equal to 20. Sorry. There is something wrong here. Actually, 1 is related to 1. So for 1 there are 20 elements, but 1, 1, 1, 2 until 1, 20. But 2 will be related to only even numbers. So 2, 2, 2, 4, then till 2, 20, and then 3 will be related to only those numbers which are multiples of 3, which is 3, 3, 6, 3, 9, then till 3, 18. Then 4 will be related to only multiples of 4, 4, 4, 4, 8, 4, 12, then 4, 16, and 4, 20. Then again 5 will be related to, therefore this is wrong, this is not correct. Okay, then again 5 will be related to 5, then all with all the multiples of 5, 5 will be related, 5, 5, 5, 10, then 5, 15, then 5, 20. So there are 4 elements. Then we have with 6 will be related to 6, and then 6 2s are 12, 6 3s are 18. Then 7 will be related to 7, 7, 7 2s are 14, 7 3s are 21, but we cannot, since 21 is not there. Then 8 will be related to 8, 8, 8 2s are 16. Then 9 will be related to 9, 9, 9 2s are 18. Then 10 will be related to 10, 10, and 10, 20. Then 11 will be related to 11, 11 only. Then after that, these will be there, means 12, 12, 13, 13 till 20, 20. So this is the set R1. So therefore, the number of elements in the set R1, that will be, now 1 is related to 20 elements. So there, so 20 elements where 1 is there, and there are 1s are 2, 2 to the 4. Okay, so there are 10 elements where 2 is there. Then there are 6, 18. So there are 6 elements which where 3 is there, where 3 is the pre-image, and 4 is the pre-image in 5 elements. 5 is the pre-image in 4 elements, and 6 is the pre-image in 3 elements. 7 is the pre-image in 2 elements. 8 is the pre-image in 2 elements. 9 is the pre-image in 2 elements. So this is 7, 8, and 9. And 10 is also is the pre-image in 2 elements. And from 11 to 20, here we have 10 elements. So for 10 elements, so there are more 10 elements here. So this will be equal to 20 plus 10 plus 10, that is 40. 6 plus, okay, 6 plus 4, 10 plus 5, 15, 15 plus 3, 18, 18 plus 2, 20 plus 2, 3 just 6. So this is 26. So this is 66. And number of elements in the relation R1 intersection R2. So that will be equal to 20. So 20 elements are there in R1 intersection R2. So that we have to subtract. So n of R1 minus R2, that is equal to actually n of R1 minus n of R1 intersection R2. So that will be equal to 66 minus 20, that is equal to 46. So there are 46 elements in the relation R1 minus R2. So the answer is 46. Then here it is told the set A is 1, 2, 3 till 100. And let R be a relation on the set A defined by x, y belongs to the relation R if and only if 2x equal to 3y. Let R1 be a symmetric relation on A such that R is a subset of R1. Y equals to 2x by 3. Y equals to 2x by 3. So uh, then only x is related to y if 2x equal to 3y, or I can say when y equal to 2x by 3. So therefore x should be obviously a multiple of 3. So therefore the set R R contains the elements. It will be 3, 2. Then it can be 6, it is a 6, so 4, 6, 4. Then it can be 9, 3, 3 is a 9, so 3 is a 6, 9, 6, and so on. It will go till so if we take 99, so into 99 by 3, that will be 33, it will be 66. So it will go till 99, 66. And if we take x as 100, if we take x as 100, x we cannot, okay, x is 100. If okay, so x equal to 3y by 2. Now if you take y as 100, y equal to 100, then x will be 3 into 100 by 2. This is 50, so this is equal to 150. So 150 is not there, so we can take that away. So it will go till 99, 66. Then it is told that R is a subset of R1, where R1 is a symmetric relation on A. So it should be symmetric. So therefore R1 that should be symmetric, and there should be minimum number of elements in the set R1. So then it means that it should contain the set, all the elements in the set R union. We should also contain the elements y comma x also. It means it should contain 2 comma 3 also, 4 comma 6 also, since it has to be symmetric relation on the set R. 6 comma 9 also, and then till 66 comma 99 also. So therefore the minimum number of elements minimum number of elements in the set R1, that will be equal to twice of the number of elements in the set R. Okay, so it will be twice of the number of elements in set R, that is going 3, 6, 9 till 99. So here we have 3 ones are 3, 3 2 are 6, 3 are 9 till 33. So there are 33 elements, the 33 ordered pairs. So it will be 2 into 33, that is equal to 66. 66 elements should be there. If x is equal to 33, then it is 22. If x is equal to 36, if x is equal to 36, then y will be equal to 2 into 36 by 3. So 12 is 24. Will be 24. If x is equal to, okay. So y is obviously less than x. Okay. Y is obviously always less than x. Okay. Okay. So there will be 66 elements in the relation. The minimum number of elements in R1 should be 66. So the answer is 66. Then here it is told, let A be the set 1, 2, 3, 4. And then R is the set 1, 2, 1, 2, 2, 3, and then 1, 4. Be a relation on A. Let S be the equivalence relation on A such that R is a subset of S. Then the number of elements in A S is n. Then the minimum value of n is. So S should be an equivalence relation containing these elements in R, and it should contain the minimum number of elements. So it should be an equivalence relation. It means that it should contain 1, 1, 2, 2, 3, 3, and 4, 4. Since why it has to be a reflexive relation, and since it has to contain 1, 2, 2, 3, and 1, 4. So it should also contain the elements 2, 1, 3, 2, and 4, 1, since it has to be symmetric also. And it should be transitive also. So it means that 1, 2, 2, 3 is there. So 1, 3 also should be there. And then 1, 3 is there. Okay, then 2, 1 is there and 1, 4 is there. So 2, 4 also should be there. And since 1 comma 3 is there, so 3 comma 1 also should be there. 2 comma 4 is there, so 4 comma 2 also should be there. Then 4 comma 1 is there, 1 comma 3 is there, so 4 comma 3 also should be there. So it means 3 comma 4 also should be there. Now 1 comma 2 is there, 2 comma 3 is there, so 1 comma 3 is there, 2 comma 3 is there, and 3 comma 1 is there, so 2 comma 1 is also there. 1 comma 4 is there, 4 comma 3 is there, so 1 comma 3 is also there. Three comma 1 is there, 1 comma 2 is there, so 3 comma 2 is also there. Now 4 comma 1 and 1 comma 3 is there, so 4 comma 3 is also there. So now we shall count the number of elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it means now here we can see here the set S is an equivalence relation on the set A. Then equivalence relation on the set A. Since why? Since the relation S is reflexive also and symmetric also and transitive also. It is reflexive, symmetric and transitive relations. So hence it means that um, R is a subset of S. So therefore the minimum value of the number of elements in the set S, which is equal to n, that will be equal to 16. So the minimum value of n is 16. 16 is the answer. Then here it is told the number of symmetric relations defined on the set 1, 2, 3, 4, which are not reflexive are. The number of symmetric relations defined on the set. So symmetric, which is not reflexive. So we can take the relation phi. Phi is the empty relation. So the empty relation is also symmetric. Which is not reflexive. Empty relation, it is also symmetric but not reflexive. So empty relation also we can take, and then not reflexive, it means we can take we can take 1 comma 2 and 2 comma 1. So we can actually take the relation which has got maximum number of elements and which is symmetric and not reflexive. Symmetric and not reflexive. So we can take 1 comma 2, 2 comma 1, 2 comma 3, 3 comma 2, and we can take 1 comma 3, 3 comma 1. We can take 4 comma 1 and 1 comma 4. and we can take, okay, 2 comma 3, 3 comma 2, and then we can take 2 comma 4 and 4 comma 2. Then we can take 3 comma 4 and 4 comma 3. And then we can take 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4. If we take, then it will be reflexive also and symmetric also. So in the case 1, we can take 1 comma 1 or 2 comma 2 or 3 comma 3 or 4 comma 4. So here we have 4 options to take 1 comma 1 or 2 comma 2 or 3 comma 3 or 4 comma 4. Any one of them we can take in 4C1 ways. And here actually we can choose any one of the given pairs, 1, 2, 3, 4, 5, 6. So out of these 6 pairs, any one we can choose. Any one we can choose by 6C1 ways, or we can choose any two by 6C2 ways, or we can choose okay, or we can choose none of these pairs by 6C0 ways, and we can choose all of them by 6C6 ways. So this will be 4 into, this will be 2 power 6. So that will be 4 into 8, it's just 64, 64. So that is 4 for the 16, 4 for the 16. Actually, here also we can choose any one of them also, or any two of them also, or any three of them also. All four of them we should not choose. We can choose none of them also. So this will be into 4C0 plus 4C1 plus 4C2 plus 4C3. 4C4 we should not add. So this will be actually, this will be 2 power 6, and into this will be 1 plus 4 plus 6 plus 4, which is actually 2 power 4 minus 1. This will be actually 2 power 4 minus 1, since 14, 15, yeah. So this is 16, so this is 15 into 8, it is 64. So this will be, so these many will be symmetric and which will not be reflexive. Any one of these pairs we can choose by 6C1 ways. Any two of these pairs we can choose by 6C2 ways. And out of these doublets, we can choose any one of them by 4C1 ways. And we can choose none of them also by 4c 0 ways. Force in and any two of them we can choose by 4c 2 ways, and any 3 by 4c 3 ways. Since all four of them we should not choose, since why if we choose all four of them, then it will become reflexive only. So this will be 15 into 64. So this will be it will be 15 4s are 60, 15 6 are 90. So this will be 960. So there are the number of symmetric relations defined on this set which are not reflexive, that will be 960. So hope all of you have understood the solutions of these questions based on the chapter sets and relations. Still any doubts if you have, please write that in the comments section. Also, please install our Sapience Education application where we shall upload some important questions based on the previous year JEE Mains exam, which shall be obviously helpful for exam. So thank you everyone. Bye. So here it is told that define a relation R over a class of n cross n real matrices A and B as A is related to B if and only if there exists a non-singular matrix P such that PA P inverse that is equals to B, and where P should be non-singular means the determinant of P should not be equal to 0. So if the det- uh, determinant of P is not 0, then only I will tell that it is a non-singular matrix. So now we have to check if this relation R is reflexive or not, since we have to check if it is reflexive, symmetric, or transitive in order to find if it is an equivalence relation or not. So for reflexive, we should have reflexive A should be related to A. Now, if you take P A P inverse and that is equal to A, so A is related to A if and only if P A P inverse that is equals to A. So now if we take P as I, which is the identity matrix, then obviously I inverse is I only. So therefore I into A is A into I is again A into I is again A. So it will be A. So hence A is related to A. So R is reflexive relation. Now we have to check if it is symmetric or not. So now for symmetric we should have that A is related to B. It means that PA P inverse that is equals to B, and also B is related to A. It means P B P inverse that is equals to A. So now in this, so this is given and we have to verify this part. So therefore PA P inverse that is equals to B. It means if we pre-multiply this with P inverse and post multiply this with P, then we will get P on both sides we will do that same thing. So it will be P inverse of P that will be equal to I. So it means that P inverse and P inverse of PA P inverse of P that is equals to P inverse B into P. So which means I, it means it is A only. P inverse BP is equal to A only. So therefore, if we take uh, P as P inverse, then we can say that it will be then only we can tell that B is related to A. Uh, Given that A is related to B. So it means that the relation R is a symmetric relation. Relation R is a symmetric relation. Now we have to check if it is transitive or not. So for transitive, A is related to B and B is also related to C. It means that P inverse that is equals to B and P inverse that is equals to C. And then we need to show that we have to find if A is related to C or not. So now A is related to C. It means that if A P inverse that is equals to C or not, we have to check that. So now here, if we pre-multiply this with P and post multiply this with P inverse, then we will get P inverse that is equals to P B P inverse. So P into P, that will be P square A into P power minus 2. This will be equal to P B P inverse. So this we can also say this is equal to P square A into P square inverse. Now that is equal to C. So it means that, so if we take P as P square, then obviously A will be related to C, given that A is related to B and B is related to C. So it means that R is transitive also. So it means that R is a transitive relation also. So it means that R is symmetric also, R is transitive also, and R is reflexive also. So therefore, R is an equivalence relation. R is an equivalence relation. So option D is the correct answer. And here it is told that in a school there are 3 types of games to be played. Some of the students play 2 types of games, but none play all the 3 games. Which Venn diagrams can justify the above statement? So in in all the Venn uh, diagrams P, Q, and R, here this region shows that it it shows that those it is a set of stu- uh, those students who play all the 3 games. These regions show the set of all students who play all the 3 games. Who play all the 3 games. So it means that none of them uh, shows none of them can justify the above statement. So the thing is that here, if we can show this type of Venn diagram, which is like this and which is somewhat like this, such that there is no common region, then only we can say that so no common region should be there, or it can be somewhat like this also. It can be somewhat like this also. So then we can say that there is no region where all the 3 sets are intersecting. So here none of the Venn diagrams can justify the above statement that n- none of them play all the three games. So the answer will be none of these. Here it is told let A be the set 2, 3, 4 till 30 and this symbol be an equivalence relation on the set A, which is defined as A comma B is related to C comma D if and only if AD equals to BC. Then the number of ordered pairs which satisfy the which satisfy this equivalence relation with ordered pair 4 comma 3 is. So the number of ordered pairs you have to find which satisfy this equivalence relation with ordered pair 4 comma 3. So it means 4 comma 3 should be related to C comma D. So it means what? That 4C uh, that AD means 4D that should be equal to 3C. Here B is 3, A is 4. So 4D that should be equal to 3C. It means what? C should be equal to 4D by 3. It means what? It means D should be a multiple of 3. It means D is a multiple of 3. So therefore we can say 4 comma 3 is related to is related to uh, so C should be 4D by 3. So we can take D as 3, 6, 9, and till 30 we can take. But till 30 we can't take, since why then C will become 40 where 40 is not there. So it means that we can take before 30, 27 can we take? So 4 into 27 by 3, that will be 3, 9, 27, 36. So 27 also we can take. 3, 8, so 24. So 24 can we take? 3, 8 is 24, 4, 8 is 32. No, we can't take. Then 21 we can take, since why 3 sevens are 21 and 4 sevens are 28. Okay, so till 21 we can take. It means that we can take the values of D till 21 and C will be 4 and then 6 by 3, that is 2, 2 is a 8 and 4 is a 12 and then till 3 sevens are 21, 4 sevens are 28. It will go till 28. So therefore 4 comma 3 is related to 4 comma 3 also. And then 8 comma 6 also. Then 12 comma 9 also. And it will go till 28 comma 21. Then we have to find the number of ordered pairs which satisfy this relation with the ordered pair 4 comma 3. So here we have 1, 2 till 7. Okay, so here we have 7 ordered pairs. So 7 ordered pairs are there. So 7 ordered pairs are related to 4 comma 3 relation under the relation this. So it means 7 is the correct answer. Option D is the correct answer. Then here it is told the number of elements in the set X belongs to R such that mod X minus 3 into mod of X plus 4, that should be equal to 6, is equal to. So here actually here we can take 3 cases. Since why here this sign will change at x equal to 0, and here the sign will change at x equal to -4. So it means the first case 1 we take that if x is less than -4, so therefore then we can say this will be minus x. So this will be minus x minus 3 into this will be minus x minus 4, means minus of x plus 4, that is equal to 6. So then we can solve it. Then we will get x plus 3 into x plus 4, that is equal to 6. So then we can say x square plus 4x plus 6 plus 3x, that is 7x plus 12 minus 6, that is 6, equal to 0. So here we will get x plus 1 into x plus 6, that is equal to 0. So therefore x will be equal to -1 comma -6. So x can be minus, so x cannot be -1, since y x should be less than -4. So x should be -6. So one element we can get. So it means the set contains the element -6. And then we can take case 2. Case 2 is that if x is more than or equal to -4 but less than 0. So then we can say that this will be minus x minus 3, and x is more than -4, so it will be x plus 4, that is equal to 6. So then we can say this will be x plus 3 into x plus 4, that is equal to -6. So then we can say this will be x square plus 7x plus 12 plus 6, that is 18, that is equal to 0. So now here the value of the discriminant, is b square minus 4ac. So this will be 49 minus 4 8s are 32, 4 on the 4 72. So therefore the discriminant is coming negative. So here we will have no real roots. So from case 2 we have no element, and from case 3, so this is case 2. From case 3 we can say if x is more than or equal to 0, then what will happen? So x is more than 0, it means we can write it as x minus 3. It will be x minus 3 into x plus 4, that is equal to 6. So then this will be x square, then plus 4x minus 3x, that is plus x, then minus 12 minus 6, that is equal to 0. So this will be x square plus x minus 18, that is equal to 0. So therefore x will be minus b plus or minus square root of b square minus 4ac, so by 2a. Now it cannot be negative since x is more than or equal to 0. Therefore x should be only root over, this is 73 minus 1, root over, this will be root over 73 minus 1 by 2. So only one value of x we will get from here. So it means there are two elements in this set. One is -6, one is root 73 minus 1 by 2. So only two elements are there. So option B is the correct answer. Then here it is told if let R be a relation which contains the elements P, the order pair P comma Q, such that P and Q are at the same distance from the origin. P and Q are at the same distance from the origin. Then the equivalence class of 1 comma minus 1 is the set. So then we have to find the equivalence class of the ordered pair 1 comma minus 1. So it means that any point x comma y should be at the same uh, distance as the point 1 comma minus 1, which lies in the fourth quadrant. So this length OP, that should let's call this as OA, that should be equal to OB. So OA, that should be equal to OB. Then only we can say, then only, or we can take this P and Q also. So this is OQ, this is OP. Now if OP that is equal to OQ, then only P will be related to Q under the relation R. So therefore it means that distance OP, that is square root of x square plus y square, that should be equal to square root of 1 square plus 1 square, which is equal to 2. So therefore x square plus y square, that should be equal to 2. So it means that the equivalence class of 1 comma minus 1 under the relation R, is the set S containing all the ordered pairs ordered pairs contains all the ordered pairs x comma y, which is related which is related related to 1 comma minus 1. So therefore we can say S will be the set of all those ordered pairs x comma y such that x square plus y square, that should be equal to 2. So option B is the correct answer. Then here it is told, if A is the set of uh, all those values x such that x belongs to R, such that mod of x minus 2, that is greater than 1. So therefore mod x minus 2, that is greater than 1, it means that x minus 2 means I can say either x minus 2 is more than 1 or x minus 2 is less than minus 1. So from here we will get x is more than 3, and from here we will get x is less than 1. Therefore the set A contains the set A, it is the elements from minus infinity to 1 union 3 to infinity, and B is the set of all those x belongs to R such that root x square plus 3 is greater than root x square minus 3, that is more than 1. So therefore we can say root over x square minus 3 is more than 1. It means x square minus 3 is more than 1. X square minus 3 is more than 1. So x square is more than 4. So it means that mod x is more than 2. Okay. Mod x is more than 2. It means that x is more than 2 or x is less than minus 2. X is more than 2 or x is less than minus 2. So it means that the set B, that is the set of uh, from minus infinity to minus 2 union 2 to infinity. And the set B, set C, that is set C contains all those x belongs to R uh, such that mod x minus 4 is more than or equal to 2. And Z is the set of all integers. Then the number of subsets of the set, number of subsets of the set A intersection B intersection C complement intersection Z. So from here we can say x mod x minus 4 is more than or equal to 2. It means x minus 4 is more than or equal to 2, or x minus 4 is less than or equal to minus 2. So therefore here we'll get x is more than or equal to 6, or x is less than or equal to 2. So therefore we will get x. So therefore the set C is, it is minus infinity to 2 union 6 to infinity. Now here therefore we have, if we draw the number line, then the set C is, this is 2, this is 6, and this is minus 2, this is 2, this is 1, this is 3. Okay, this is 1, and here we have 3. So the set A is minus infinity to 1 union 3 to infinity. 3 is excluded, and this is in minus infinity to infinity. And then set B is minus infinity to minus 2, minus 2 union 2 to infinity, 2 to infinity. And then here we have minus infinity to 2, minus infinity to 2 union 6 to infinity. So it means the intersection part of all the three sets is this region and this region. Therefore A intersection B intersection C, that is nothing but minus infinity to, here also minus 2 is excluded, here also 6 is included, 6 is included. So it is minus infinity to minus 2, here 2 is included, 6 is included. Here 2 is not included, this minus 2 is not included, but here 2 is included. So this is minus infinity to minus 2 union 6 to infinity. So here 6 is included. So we can say A intersection B intersection C whole complement, that will be equal to the region excluding this part. So that will be from minus 2 to 6, like this. So therefore A intersection B intersection C complement intersection Z, where Z is the set of all integers. It means we have to find all the integers from minus 2 to 6, including minus 2. So that will be minus 2, minus 1, 0, 1, 2, 3, 4, 5. So here we have 8 elements. So it means here we have 8 elements in this set. And then we need to find the number of subsets of this set. So therefore the number of subsets of this set, that will be obviously equal to 2 power 8. Since it has 8 element, so its number of subsets will be 2 power 8. So that will be equal to it is 4 power the 4 power 4. You can say this is 8 into 8 into 4. 3 plus 3, 3 is 6 plus 2. Okay. So 8 is 64, 64 into 4. So that is 4 4 is 16, so 24, 256. So there will be 256 subsets. So the answer is 256. Then here it is told the set A, it contains all those natural numbers n such that n square minus n that should be less than or equal to 10,000. And set B contains all those uh, natural numbers k such that k 3k plus 1. So those natural numbers which are of the form 3k plus 1. And C contains only the even natural numbers where k belongs to n. So then the sum of all the elements of the set, sum of all the elements of the set A intersection B minus C is equal to. So here n square minus n is less than or equal to 100 into 100, we can say. Therefore, this is n into n minus 1, that is less than or equal to 100 into 100. Means, so therefore n should be 1 and should be 1, 2, 3 till 100. Since why 100 into 99, that will be 9,900. But if we take 101, then it will be 101 into 100, which will be 10,100, which will be more than 10,000. So till 100 it will go. So therefore now B minus C, it means uh, those natural numbers. B minus C, it is a set of those natural numbers of the form 3k plus 1, but not an even number, but which is not even number. And A intersection B minus C, we have to find set of those natural numbers, from 1 to 100, of the form 3k plus 1, which is not even, means which is an odd number. It means that we have to find those odd numbers of the form 3k plus 1 from 1 to 100. That will be the elements in the set A intersection B cross C, A intersection B minus C. Now therefore 3k plus 1, so if we take k equal to 1, then it will be 4. So we can't take that. If we take k as 2, then it will be obviously 2 3 6 7. 7 we can take. So 7 we can take, then 7 we can take. So it means the set B minus C, we can say the set B minus C, it means those elements of the form 3k plus 1, which is not an even number. So that will be 7, then it will be 3 3 is a 9, 9 plus 1 10, we can take. 3 4 is a 12 plus 1 13, we can take. Then 3 5 is a 15 plus 1, we cannot take. 3 6 is a 8, 18 plus 1, yeah, 19 we can take. Then 3 7s are 21, we cannot take. 3 8s are 24 plus 1 25, we can take, yeah, and etc. till 100. And so on. Okay. So therefore, A intersection B minus C, that will be the set 7, 13, 19, 25 from 1 to 100. So if you do 3 into 33 plus 1, that will be obviously 99 plus 1, that is 100. So we cannot take that. But you can take 3 into 32 plus 1, which will be 3 1 3 2 is 6, 3 3 is 9, 96 plus 1, that is 97. So till 97 it will go. And before 97, that will be 3 into 31 plus 1 we cannot take, since it will be 3, 3 3 0 9, that will be 94. So we cannot take that. 3 into 30 plus 1 we can take, since it will be 91. So just before 97 we will have the number 91. So therefore the sum of all the elements in the set A intersection B minus C will be 7 plus 13 plus 19 plus 25 plus 91 plus 97. So obviously it is an AP only, since why here the common difference is 6, and the first term is 7. So therefore it will be, and how many elements that we have to find? So let's say it is the nth term. So this will be 97, that will be equal to A plus n minus 1 into D, n minus 1 into 6. So n minus 1, that will be equal to 90 by 6, that is 15 6 90. So n will be equal to 16. So there are 16 numbers here. So therefore the sum will be equal to 16 by 2, n by 2 into A plus L, which is 7 plus 97. So it will be 8 into 104. So that will be 4 8s are 32. 8 1s are 8. So that is 832. So 832 is the answer. Eight hundred and 32 is the answer. So here it is told that let A is a set of all those natural numbers n, such that n is a 3-digit number. So A is a 3-digit, the set of all 3-digit natural numbers, and B is the set of all those natural numbers of the form 9k plus 2, where k belongs to n. So here and C equals to 9k plus L, where k belongs to n, where L is a number in between 0 and 9. So L can be 1 or 2 or 3 or 4 or 5 or 6, 7 or 8. So from 1 to 8 it can be any number. Now we have to find that L. Now here it is told that the sum of all the elements in the set A intersection B union C. Now A intersection B union C, that we can write A intersection B union A intersection C. So A intersection B set, it means that A intersection B means it is a set of all 3-digit natural numbers of the form 9k plus 2. And A intersection C also, it will be the set of all those 3-digit natural numbers of the form 9k plus L. 9k plus L. 9k plus 2. This is okay, 9k plus L. So now, therefore, if we do 9 into 10 plus 2, then we will get 92. But here 3-digit numbers you have to take. So if you do 9 into 11 plus 2, then we will get 99 plus 2. So that will be 101. So it will start from 101, and then 12 nines are 108 plus 2, that is 110. So therefore, the elements in the set A intersection B, that will be 101, 110, then 119, since 13 nines are 117 plus 2. Okay, then it will go till 9 into 111. If you do 111 plus 2, then it will be 999 plus 2, but it will come a 4-digit number will come. So it means 110 we should do it. So it will be 992. So it will go till 992. And A intersection C, that will be of the form 9 into 11 plus L, 99 plus L. 99 plus L, if you do, that will come obviously a 3-digit number. A 3-digit number will come. Else, if you do 9 into 10, 90 plus L, it will be obviously a 2-digit number. So 3-digit numbers only we should take of the form 9k plus L. So it will, the first number will be 99 plus L. Then the next number will be 9 plus 9, that is 108 plus L. And it will go till 990 plus L. 990 plus L. So these are the numbers. And the sum of all the elements in this set, the sum of all these. So therefore, the sum of all the elements 101 plus 110 plus till 992 and plus this sum 99 plus L plus dot dot till 990 plus L. This sum will be, this sum is given as 274 into 400. Then we have to find the value of L. So therefore, obviously, this is an AP having with common difference 9, and this is also an AP with common difference 9, with common difference equal to 9. So here, here obviously here we have 100, and so this will, how many terms you have to find? So that is n is equal to actually nth term is equal to a plus n minus 1 d. That will be 992 minus 101 by 9 plus 1. So here the number of terms will be this is 891 by 9 plus 1. So this is 9 nines are 81, 9 nines are 81 plus 1, there is 100 terms. 100 terms are there here. So there will be 100 by 2. The sum will be equal to n by 2 into a plus L. Plus here also there will be this 990 plus L, n will be 990 plus L minus 99 minus L by 2 plus 1 by 9 plus 1. So this will be 99. This is 1. And 10, 9, 8, 891 by 9 plus 1. So this will be also 100 terms. So here also 100 terms. So this will be 100 by 2 into 99 plus L plus 990 plus L. So that will be 274 into 400. Then we have to find out L. So this will be, we can take 100 as common. Then we will get 101 plus 992 by 2 plus 99 plus 990 plus 2L by 2, that is equal to 274 into 4. Since 100 and this 100 will cancel out. So this will be 3,91093 plus this will be 9, 2 9s are 18, 1089 plus 2L, that is equal to 274 into 8. So therefore 2L, that will be 274 into 8 minus this 1093 plus 1089, that will be equal to 12 into the 18, 3182. Yes, 3182. Therefore L will be 274 into 4 minus 2 1s are 2, 2 5s are 10, 2 9s are 18, 2 1s are 2. So therefore L will be, so this is have to do 274 into 4. So that will be 4 4 the 16, 4 7 the 28, 29, 4 the 8, the 20, 4 4 16, 4 7 28, 29, 4 the 8, 9, 996. Sorry, this will be actually 2182. 18, yeah, 2182, sorry. This is wrong. The sum will be 2182. This will be 2 1s are 2, 2 zeros are 0, 2 9s are 18, 2 1s are 2, 1091. This will be 3 9 1093. This will be 9 9 plus 18, 990 plus 99, that is 9. So 18 089. It's 12. So 18 2. 274 to 4, 4 for the 16, 28, 29, 2 for the 8, 10, 1096. This was wrong. Okay. So this will be, so therefore L will be equal to 1096 minus 1091. So it means that L will be equal to 5. So therefore the value of L will be equal to 5. So hope all of you have understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter sets and relations. Still any doubts if you have, please write that in the comments section. Also please install our Sapience education application, where we shall upload some important homework questions based on the previous year JEE Mains exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.